So in this session we will be talking about the AUC, which is actually area under the curve, or ROC, receiver operator characteristics. So this is again a metric which will help you to identify how well your classifier works, and this basically shows you about two different things. One is actually it is a probabilistic curve. Second one, a probabilistic curve actually which plots both the true positive rate and the false positive rate. So true positive rate will be plotted against the false positive rate, right? And this means that if you have a bigger area of area under the curve, then actually the class is able to classify its its classes in a better way, right? And this is something which is basically used in most of the machine learning algorithms, and to identify about the how well your classifier is performing against the data. So now we'll talk about how well this is, basically how can we actually infer the AUC or ROC curve. So when you look at this particular data, you have the true positive rate and you have the false positive rate, and you can see this particular one here, 0 to 1, right? So this is against, it's just 0 to 1. So say if your curve is having a straight line here, say just imagine that it's like a complete square which actually comes over here, then that means that so your AUC is equal to 1. So if your AUC is equal to 1, so if it comes over here, AUC is equal to 1, that means that your classifier is able to perfectly distinguish between all the positives and the negatives, right? And now you could see this diagonal line which actually crosses through the middle, right? So this dotted line. So when you look at the dotted line, that is actually when your AUC is 0.5. Okay, so when you see that your AUC is actually 0.5, that means that the classifier is not able to distinguish between the positive and the negative classes. Okay, so if you want to get this is from ResearchGate, one of the research papers. So when you look at here, so this is your AUC is equal to 1. Okay, so if your AUC is equal to 1, that means that you are having a perfect one. And if your AUC is equal to 0.75, it looks something like that, then also your area of the curve is actually 1. So that means it has got a good performance. Still it is not able to calculate identify certain set of data as there are certain false negatives and false positive. That means that's the meaning of it. And then if it is 0.5, it's like the perfect diagonal one. So that means it is, you are not able to correctly identify. There is a bit of a confusion for it. So that's the meaning of it. So this is all about your performance of your classification. How your AUC and ROC works. So in this video, it is very understandable that if you get 1, it is actually classifying the positives and the negatives in a real good way. And if you have something between like 0.5 and 1, then the classifier is able to distinguish the positive classes really well from the negative classes. And if it is 0.5, it is not able to distinguish the positive and negative. If it is equal to 0, that means the classifier is predicting all the negatives as positives. Okay, so this is what you will understand from AUC. So this is something more. So if AUC is equal to 1, you have equal predictions which are happening. 0.75, it is still better. The classifier is able to identify in a good way, but still there is certain issues for the classifier. It is still performing a good performance, not the excellent performance like AUC is equal to 1. And 0.5, it's finding it very difficult to differentiate between the positives and negatives. So now going back to the program, so we are basically using pandas, and from the sklearn.datasets we are actually using the make classification, and we are also using the model selection in that, because we are using this particular function, train, test and the split. So say we are just randomly taking some samples, and then we are actually making it into 2 different classes. We are making it into training and the testing of both the classes. And so this is the data, so it's kind of a raw data, and now we will perform 2 different models. One is actually you are taking the linear model logistic regression, because it's all numerical values, and also we are actually trying to find out the KNN algorithm, so k nearest neighbor, so k neighbors classifier. So model 1 will basically go for the logistic regression, model 2 will go for the neighbor classifier. So if you are actually giving the KNN, then you have to also specify the n is nothing but the number of the neighbors, and you're just simply fitting the values over to the training. So you're actually training the model with both the models. So model 1 logistic regression, and 2 is the, and then we are actually making the model to predict based upon the test values, and then comes then we are going to I mean like evaluate that particular classifier by using the ROC curve. So there is a function called ROC curve in sklearn metrics, and so ROC basically helps us to plot between the false positive rate and the true positive rate, right? So we are actually keeping the threshold as 1. So this is how it is. So you have your you're into the ROC curve, you have to give the Y test, right, because you need to test them. And the predict probability of 1 and the positive label 1, right? This is what actually we are giving. So and for that, you are actually going through all the ranges for Y test, and you are actually calculating that for every values, and you are calculating the predict of the FPR and predict of TPR. So this is what it is. Now you are going to calculate the AUC scores as well. So you do have this from the sklearn matrix, you do have a ROC AUC score. Okay, so that is what you are basically using. So for that, you are getting almost like logistic regression, you are getting 97 and 92% for the KNN. So now coming to the ROC AUC curve, you are giving the classification. Okay, just a second. So here, if you could see that for plotting them, you are actually you are actually you are using this matplotlib, and there is a library, Seaborn library, which we will use for predicting and using stuff. So when you look at here, so you could see that this yellow color is your logistic regression, and this is the KNN. So you could very clearly identify that how well each of the model classifier works, right? So and then comes the multi-class classification problem. So for that, we are just instead of 2 classes, we are actually taking 3 classes. That is the only thing. Other than that, all everything goes exactly well, and it's almost the same thing. But here we are actually one with rest classifier is also used, and you have logistic regression, and so it's all the same, major difference. So when you look at here, I mean like you have the class 0, you are actually taking the class 0, this blue line is your class 2 versus the rest of the classes, and this is your class 1, I mean like 0, this yellow is a class 0 using with the rest of the classes, and this green color is actually the class 1 versus the rest of the classes. So like that you can actually do and use this ROC curve for or AUC-ROC curve for this for representing multi-class classification problems also. So here also you understand that your class 2 versus actually comes out with the best classifier performance. So that's all about this AUC-ROC curve. So hope you got a little glimpse about it. So hope you can actually bring more onto it. The GitHub code is available, so if you want you can actually take the code and make your hands dirty. And thank you so much. If you have any queries, you can always let me know. Thank you so much.